Next up, we will go ahead and talk about redox. Redox reaction. And before we talk about redox reaction, it's important to review how to label oxidation number. Do you still remember how to label oxidation number? Okay, so now let me make one point very clear at the very beginning to set the stage. A lot of teachers, they don't really make this clear. I want to make this clear. Oxidation number is not charge. Okay, in terms of the definition. Now, oxidation number may borrow the value of charge as the oxidation number, but fundamentally, in terms of definition, they're different. Charge is an imbalance, it's contributed by the imbalance of protons and electrons. Okay, so if you have more protons and electrons, you have a positive charge. If you go into an atom and ask the nucleus and say, hey, do you know what's your oxidation number? And they will respond to you and say, I don't know. What's an oxidation number? Did y'all humans do something weird to us again? So oxidation number is a man-made accounting system. It's just a game rule. And for this rule, we have a few major rules. First, to begin, compounds. It's always zero. Okay? So when you add up all the oxidation number for a compound, it should add up to zero. In a compound, or a pure element is also zero. So for example, if I say H2, what's the oxidation number of H in the H2? Zero. Okay, the logic is, well, it's a molecule, right? So it's supposed to add up to zero. 2 times what equals zero? Zero. Okay, so H2, O2, K, Ca, they all equal to zero in this case. All right? Now, if it's in the compound, the ions, or the simple ions, okay, the oxidation number would be the value of their charge. So if you have Na plus, it'll be +1. And by the way, do not say 1 plus, because there's a subtle difference when we describe charges and oxidation number. Charge, you start with the number followed by the charge. For oxidation number, is charge followed by the number. It's kind of subtle. Some teachers, they don't care. I do. So if I have Cl minus, it's going to be -1. Okay. If you have a polyatomic ions, okay, overall oxidation number is equal to the charge, value of the charge. So if you have sulfate, so whatever you add from sulfur and oxygen must equal to -2. But how do we figure out the individual ones? Well, that's the meat of the oxidation number with the game rules that we talked about all the time. If you have an oxygen in a compound, it's going to be -2. If you have a hydrogen, +1. +1. Now, with a couple exceptions. That we don't usually see. The oxygen in peroxide it's going to be -1. And that should make sense because peroxide is O2 minus, right? It's a polyatomic ion. So we think about 2 times what if it goes to -2? -1. Hydrogen, typically it's a +1, except hydride. Okay, hydride would be a -1. So for example, if you have sodium hydride, sodium would be +1, hydride would be -1. So these are the game rules. And if we do not specify anything, that means you go figure. So the example I just listed right here for sulfate, then we say, oh, well, I mean, we know the oxidation number for oxygen is -2. And by the way, even though there are 4 oxygen, when we label the oxidation number for each oxygen. Okay, so instead of writing -8, you will only write down -2, because we might need to compare the change of oxidation number. Well, it's 4 times -2. Okay, each one is -2, but there are 4 of them. So then we say, yeah, if that's the case, what is the number for sulfur? Well, it has to be +6. Okay? So far, so good? All right, now. Covalent compound? Sure. So that's a very good question. Let's see, what is it called? P405? No, P405 is not a good one. Let's just say CO2, for example. Okay, so what we must know is that oxygen is -2. So that means carbon must be +4. Okay, so that's how we deal with covalent compounds. Ionic compounds, even easier. We just look at the ions. Okay, but you need to know how to break you need to know how to break things down sometimes. Like, for example, if I have something like this, then we know K is +1, oxygen is -2, and then we figure out the manganese, which is +7. Okay, so we have that. Okay, so are we good with the labeling of oxidation number? Yes. CR2O7 with a 2- charge. Oh, no, K2. Okay, so K2, yes. So yeah, so that's the thing I want to also talk about. You can look at this as a whole thing. You may also look at it and say, wait, hold on, this is clearly a dichromate ion. You can look at it this way too. So either way, you would get +6 for the chromium. Either way. Okay. Good. All right. So that's the labeling of oxidation number.